This presentation shows the fishery management policies critiqued and or suggested by Robert Stavins in his article. It's useful to review the long-run equilibrium. This in particular is a long-run equilibrium in an open access fishery. So all factors are paid, their opportunity cost, boat owners are paid, the normal return to capital, normal profits are paid to the boat owner, for example, and the normal wage is paid to the fisherman. I've added one line here that the resource rent, that is the net revenue generated by the biomass growth, is equal to zero. So the condition is, or the result is, the total revenue will equal total cost. And the normal profits, or the boat owner will receive normal profits. In this case, the price will equal the cost per unit of output. This is the same figure that I showed in the last presentation. It shows a bioeconomic model where there's yield, the biology in terms of yield, and there's the cost in terms of economics. The result is that the competitive equilibrium is where total cost equals total revenue, and at that point the total revenue is less than the maximum sustainable revenue, and the biomass is less than the biomass necessary to generate maximum sustainable yield. The management goal would be to reduce the catch to increase the yield, or reduce the catch which would increase the stock to increase the yield to maximum sustainable yield. And there's lots of options that are typically used in this. One is to set a catch limit, that is reduce the catch in order to increase the stock size, or to restrict fishing through gear restriction or area restriction or time restrictions or fish size restrictions, or there's a whole series of possibilities to reduce fishing effort. Stavins presents a couple of examples of management used to achieve the management goal to reduce the catch in order to increase the stock size, increase the biomass to the optimum biomass, which is the biomass at MSY, at least as done by most management regimes. So there's different options. One is to set an annual catch limit, an annual catch quota. The other is to reduce fishing effort through restrictions on fishing effort as suggested in the previous slide. The result of both of these methods, or these options, the first, for example, to set an annual quota, that fishermen will race to fish. That is, the bigger, faster boats, they'll race out to the fishing ground when the season opens, catch as much as possible in as short a time as possible, and they'll return to shore with their catch generally all at once. Stavins presents the classic example of the halibut fishery on the west coast that I think was eventually, the season eventually was reduced to something like 4 hours per year. The result of this in terms of the figure is that the cost rises so that the cost intersects revenue at MSY. But there's wasted resources. The boats are wasted, the catch is wasted in the sense of it's not in very good shape, it's sold all at once, so the price is low, and so on. The other possibility of restricting fishing effort, once again, to increase the cost of fishing. So at the best that can result from this is that the cost will increase so that it's just equal to revenue at MSY. Once again, resources are wasted. Boats are idle, or people use inefficient methods to catch fish. The fish is not necessarily in very good shape, and so on. So it's inefficient. Stavins presents two possible solutions, or two categories of solutions. The first is a tax solution, though. So the idea here is to set a tax equal to the increase in cost that would happen through open access with fixed quotas. This is not a trivial problem because it's difficult to figure out what the tax rate should be. This is a tax rate on catch, and also, of course, a political problem because no one wants to pay a tax, and people will fight the tax or figure a way to get around it, and so on. So the cost increases due to the tax. In this case, if, at the best possible scenario, is that the tax revenues could be used to fund public policies. For example, reducing the tuition and fees at UMass. Tax would also could be used to enforce the policies, for example. This has been tried in a few places. It's rarely tried. Stavins does give a few examples. The other result that Stavins presents is a property rights solution. And the property rights solution is basically to set the total catch. In this case, usually it's set at MSY, which is not the best, not the optimal rate, by the way. Once again, we'll look at that later on. But the usual case is to set the catch, or to try to increase the biomass to the biomass that's necessary for MSY. So the property rights solution is to give fishermen transferable rights to catch a portion of the total catch. These are called ITQs, individual transferable quotas. The result is the most efficient fishermen will collect shares of resource rents. That is, they'll buy quota, and because they're more efficient in using the quota, and they'll receive the resource rents. So in this case, there will be resource rents. It won't be competed to zero. It's important to note that in this case, as in all cases of fishery management, the enforcement costs may be quite high.